Here's some help with problem 11-12. By this time, I hope that you have figured out that our test statistic that we talk about here is just a z-score. Nothing other than taking a sample mean, subtracted, take away the mu from the sample mean, and divide it by our standard error of the mean, what we do to adjust the standard deviation based on the sample size. So it's just a z-score. So since it's just a z-score, really this whole idea that they told us that in problem 12 that the mu was 0, the mu was 0, and that would correspond to a z-score of 0 as well. And then this question is all about what's going on when we have a test statistic, which is a z-score of 1.6. And what I found from my table, from my standard normal table, is that the area under the curve to the left of 1.6, that's what my table reports, is 0.9452. And we have three different in 11-12 part A. What's the p-value if the alternative is that mu is greater than 0? B, what's the p-value when the alternative shows that mu is less than 0? And C, what's the p-value if the alternative is two-tailed, it's called? Mu is not equal to 0. And really this is as simple as looking at the area under the curve that we have for mu is less than 0. Mu is less than 0 corresponds exactly to where I already had shaded. If the mu is true, a sample like this would happen 94.5% of the time. That's not any good evidence right there. That would fail to reject the null. A sample would happen 94% of the time if the mu were true, or if the null were true. And then when I do the subtraction, 1 minus this, I'm going to get 0.0548 on this tail. And actually that's the piece that corresponds, this part, is going to correspond then with the alternative that the mu is greater than. So the direction of our area under the curve, the percentage that we're going to get from that area under the density curve, is determined by your alternative. In the case that we have a two-tailed alternative, the two-tailed alternative, we don't have any insight in terms of, is this increasing, decreasing, what can we expect related to the status quo. So in a two-tailed situation, we take our test statistic and we take the opposite of it, and we consider that it's actually likely that we could be going in the other direction in terms of gathering evidence. And we consider that our p-value, two-tailed is the name of it. It's because you take the area of both the tails, and that is what makes up your p-value, 0.0548. So if I do 2 times 0.0548, I get 1096. This p-value right here, mu is greater than, we have much stronger evidence against the null. We could reject the null in certain instances based on this p-value. What this says is that if the null hypothesis is true, a sample mean like this would only happen 5.48% of the time, and that's not very likely. So that's the strongest evidence. We have some evidence against here. We would fail to reject with a p-value this high in the case of B. I hope that helps.